Hello students, I am again here with some more important questions in data structures. This is again helpful for your university exams also. The first question is, what is a queue data structure and what are its possible operations? In the last session we have discussed about stack data structure. Stack is a linear data structure that follows last in first out. This queue is again a linear data structure. You can also say that it is an ordered collection of elements. It follows first in first out. Whatever element inserted first, that will be removed first. Now for understanding this queue data structure, I am going to explain one real-time example. See, you know there is a cinema hall and in there is one ticket counter. Consider this is a ticket counter and here suppose there is no one in the queue of that ticket counter. Suppose you are the first person, you have entered in this ticket counter queue, then you will be the first person entering in the queue. Then suppose one more came at this place, at second place, suppose one more came at third place, one more came at fourth place, and so on. You are the first person entered in this queue, that's why you will of course get the ticket first, then the second one, then the third one, and so on. Getting means the person who have entered first in this queue, that will get the service first, that will get the ticket first. See, this type of approach is used in this queue data structure. The similar approach is there in queue data structure. That's why this is called as a first in first out. You can also call it as a last in last out, means whatever person came last, that will get ticket last and will get removed from that queue at last. Getting? You can see here this queue is having two ends, means whatever person entering in this queue, that is from this end always, and whatever person getting service or getting ticket, that is removing from this end. Getting? This queue data structure is just like a real life queue. See, this is a diagrammatic representation of this queue data structure. You can see that there are two ends, front end and rear end. One end is needed for insertion and one end is there for removal of elements. From rear end always elements are inserted and from front end always elements are removed. Okay, means suppose there are some elements in this queue, like suppose there is a 4, 7, 6, 5. These are the elements present in this queue. Then this front will point to this front element, means 4, and rear will point to this 5 element which is at the end, which is inserted last. Okay, only front element you can remove and you can insert element through this rear position, means after that rear you can insert the element, and after insertion of element, the whatever newly inserted element, to that element rear will point. Getting? The operation of removal of element from that queue is always called as a dequeue operation. The operation or process of inserting element into the queue is called as a enqueue operation. Getting? These are the main two operations of queue data structure. See, this dequeue operation means removal of element or deleting element from that queue, and enqueue means inserting element in the queue. In case of stack, we have seen push for insertion and pop for removal. Getting? Here enqueue and dequeue. Now the next operation is nothing but is full. Is full means here you can check whether queue is full or not. Empty is empty means here you are going to check whether queue is empty. Okay, this means there is no any element in that queue. Now the next one is a peek operation is there. Peek already we have seen in the stack data structure, means just displaying the topmost element in the stack, that is called as a peek operation. Here displaying the front element from the queue, that is called as a peek operation. Getting? First operation is a enqueue. Enqueue operation means it just inserting element into the queue. You can insert only element through rear end. Okay, next one is dequeue. Dequeue means just removing the element from the queue. You can remove the element from front end. Getting? Next one is a just is full, you can say. Whenever we are going to implement that queue data structure with the help of array, you can say array, which is a static implementation of queue. In that there is a fixed size of queue. Okay, if you are considering the queue having fixed size, then you can check whether that queue is full or not. That operation is called as a is full operation. The next one is empty. Is empty means if there is no any element in that queue, then we can say that queue is underflow, or you can say that here queue is empty. That operation is nothing but is empty. The next one is a display operation. Display means just displaying the elements of queue from front to rear. Then next is a peek operation. Peek operation means just display the front element without removing it. Getting? These are the operations possible on Q data structure. See, I am just explaining these operations with the help of array data structure. Somewhat implementation I am going to explain here. Actual implementation of this Q with the help of array, that I will explain in any other video. Okay, now consider this is a array. Okay, now currently let it is having size 5. I am creating here array of size 5. Now with the help of this array, I just want to implement all these operations of Q. Now how to do that? See, you know, array index starts with 0 and ends with size -1. Means here the last index will be 4 and the initial index will be 0. Now we can insert the elements here one by one, but here always keep in mind the elements which are on the front end, those you will remove. Front means pointing at this position and rear means pointing at this position. Okay, now see, whatever you are starting to insert element in this Q from 0th index, then first index, then second index, and again you are going to remove the element from the front end. Means you will remove the first element whatever present at 0th index always. Means you have to just implement the Q data structure in the same way you have to use array here. Getting? Now how to do that? See, we have to maintain two ends like front end and rear end, and for that, see, we will just declare two variables like front and rear, and both will be initially -1. Front will hold the index of the front element and rear will always hold the index of the last element. Getting? But initially there is no any element, means Q is empty, and in that case front and rear both will point to -1. See, if both are -1, then we can say that Q is empty, means Q underflow. Getting? Means in is empty, we have to check whether front and rear both are -1. Next one is, see, suppose I want to implement NQ operation, then how we can do that? You see, NQ means, suppose I just want to do this NQ 5, means 5 element I want to insert in this Q. Then how we can do that? We have to just increment the front and rear both, front plus plus as well as rear plus plus, means both will be 0, and at 0th index in this array we have to insert this 5 element, means 5 element will be inserted at this place. How we can do that? Suppose the name of array is A and having size 5, in this way this array is supposed. Then at A of, you can say front equal to 5. In this way you can insert element in this Q. Suppose you are inserting one more element like NQ, suppose you have again called like NQ, let's 6. Then what we have to do? See, front will be fixed because now currently front is 0. Whenever you are going to insert any element, just change rear always, don't change front. At the beginning only you have to increment front and rear both, but where there is an element present at front position, means at 0th index, then don't change the front. Whenever you want to do NQ operation, always increment only rear. Getting? Means we will do rear plus plus. Now front is 0 and rear is also 0, but whenever you will do rear plus plus, then rear will become 1. Getting? Rear plus plus we have to do, means rear will become 1. This is now rear and this is now front. Getting? And at this place you can insert the element like A of rear equal to 6. Here also you can write rear because rear and front both are initially pointing to 0 only. Okay, because see, there is only one element, means both will be same. Now next time, for A of rear equal to 6 means 6 is the element we have to insert at this place. Getting? Next time suppose you are again calling that NQ operation, means what you will do? Into suppose 10. Then what will happen here? Again rear plus plus, means rear will become 2 in that case, and here you have to insert the element 10. Getting? Means see, you can say that same representation here, just like this is diagrammatic representation, means front is 0 and rear is 2. Now suppose you want to remove the element, means you just want to call this TQ operation, then there is no any requirement of passing the argument, because always it is fixed that only front element you are going to remove. Okay, means it is compulsory that whatever element present at front, that will be removed. That's why here only you have to just increment the front, means if you want to remove this element, means you will just display the message like the deleted element is A of front, and then you have to just change the front. Getting means what you will do, a of front element you will just display as a deleted element, and you will just increment the front like front plus plus in this case. Now what will happen, see, you have just displayed that deleted element is 5 and now front will become 1. Now there are only 2 elements in this queue. In this way you can implement dequeue operation. Getting, but here see, you have to check whether queue is empty or not. That is always compulsory. Queue is empty means front and rear both are equal to -1. In that case queue is empty. Again there are some conditions, in that case also queue is empty. Those we have to just see in the static implementation of that queue data structure. That I will explain in depth in next video. Getting, now the next thing is, see, dequeue operation you have to do in this way. Next one is full means, see, suppose there is one more element you have enqueued, like let 8, one more element suppose you have enqueued at this place, means now here let 15. Now see, here there is a empty position but this is full. Okay, means rear is equals to 4, means you can say that queue is full. Getting, you cannot do the like this, means you cannot shift these elements here. You have to consider like this only whenever you are doing implementation of queue with the help of array. Now in this case rear is 4 means size -1, array size is 5 here. In that case you can say that queue is full. Now one more point is there, suppose you have called dequeue operation again, means this will be removed, this will be removed, this will be removed, means front is now pointing to 4 and rear also pointing to 4, means whenever front and rear both are same, then you can say that here queue is having only one element. See, here queue is having one element, but here again suppose you want to insert one more element, you cannot do that whether there are these spaces, empty spaces. Okay, then also you cannot insert any more element in this queue. But see, you can do one thing, that suppose there is only one element in the queue, how you can decide that front and rear both are same? Means in that case what you will do, you will have to just remove this element and assign -1 value to front and rear both. In that case again you can insert more elements in this queue. Getting, in this way you can do the multiple operations on queue data structure with the help of array. Now enqueue means you have to just increment the rear position and add element at that place, means you can insert element only from rear end. Getting, that is called as a enqueue operation. You can remove the element from front end. In that case you have to just increment the front, and whatever element at front, that is nothing but the removed element. That is called as a dequeue operation. Is full means here you will check whether rear is equal to size -1. In that case you can say that queue is full. Empty means what, both are pointing to -1, front and rear. In that case queue is empty. Then see, there is a display operation from front to rear, you can display all the elements one by one. And peek operation means just display a of front, means element whatever present at front position. Getting, these are just possible operations on queue data structure. What is queue? Queue is a linear data structure which follows first in first out, means whatever element inserted first, that will be removed first. That's why it is called as a first in first out data structure. Queue is having two ends, means front and rear. For insertion you have to use rear end, for deletion you have to use the front end. The possible operations on queue data structure are enqueue means inserting element, dequeue means removing element, then is full means check whether that queue is full or not, is empty, check whether that queue is empty, display means just display all the elements of queue, and peek means only display the front element without removing it. Getting, these are all possible operations of queue data structure. Now the next question is, what are the applications of queue data structure? See, we have just discussed queue is a data structure which follows first in first out approach. It is a linear data structure. This is again widely used data structure, just like a stack data structure. Some of the applications of queue data structures are like this. In CPU scheduling, see, there is only one processor like CPU, and there are multiple processes coming towards that CPU for processing. Now the processes should be queued so that those are executed sequentially one by one, and for that CPU scheduling the queue data structure is internally used. Now the next one is, in call center there are multiple requests coming by people, okay, and those should be queued for getting processed, and in that call system queue data structure is used internally to hold people for calling them in a queue. Getting. In the next is a BFS. We have seen that in depth first search of graph data structure, STAG data structure is internally used. In graphs for breadth first search, Q data structure is used. This is just a traversal algorithm. Okay, and in that data is traversed level by level. Okay, in BFS, and in that Q data structure can be used. The next one is resource sharing. For example, suppose there is only one printer and 5 computers are suppose connected to this one. Suppose all the printers are giving request to that printer for printing some documents, then at a time all the requests cannot be handled by that printer. One by one those should be handled. Means whatever request came first, that will be served first always, and means all the requests whatever coming, those are queued, and then one by one all the print requests are processed by that printer. And in this device sharing, or you can say that resource sharing, internally Q data structure is used. Getting. These are some of the applications of Q data structure. In any separate video I will just explain the static implementation, again dynamic implementation of Q data structure. In the next session we will see some more important questions of data structure. Till that, take care. Bye bye. Thank you.